Las Vegas. Welcome to our session, Build and Optimize Edge Architectures for Resiliency with AI. It's a 400-level code talk, and if this is your first code talk, it's also my first code talk. We're super excited to take advantage of this format. Previously, we've had things like chalk talks, where we've had a chance to whiteboard, hey, this is what we think this could look like, or a workshop, hey, come follow along with me as we build. But now we have an opportunity to code in front of you. This is live, anything could happen, but we think it's a really exciting format to learn and build together. And because we have a nice, small and intimate room setting, we highly encourage questions. So if you want to see us build or tweak something different, we'd love to hear your feedback. But by way of introduction, I'm Robbie Belson. I'm a developer advocate based in New York City. I focus on hybrid and edge services, and specifically its application with generative and agentic AI. And my co-pilot for this afternoon is the one and only Jesus Federico. You want to introduce yourself?
Sure. Hi, everyone. My name is Jesus Federico. I'm a principal solution architect with focus on generative AI. I used to work for the telco vertical. Now I'm focused fully on Gen AI.
Fun fact, we used to both work together in the telco vertical. So we've been working hard on related topics here for well over a year, and excited to share not only what we've developed here, but what we've been learning from customers and some of their feedback and how it applies to some of these best practices. So before we start coding, since we have an hour together, I think the theory is very important, what we're doing and why we're doing it. And I think it's always helpful to start with a level setting exercise, because I find, even as we go turn back the clock to reInvent 2019, 6 years ago, when we first announced a lot of these AWS hybrid and edge services, outposts, local zones, wavelength zones, all part of this cloud continuum. We wanted to create a consistent set of AWS services, the same set of APIs, operational consistency, and the same services you know and love, exactly where developers and builders need it most. So just by way of hands, how many of you have had a chance to experiment with a local zone or an outpost or a wavelength zone? Okay. And I think I said 2 or 3 hands. That is super consistent across all the 6 reInvents that I've had a chance to build with. We often find that these sessions, folks come who are new to all of these services. So we always figured, even though it's a 400-level chalk talk, we want to start, or code talk rather, we want to start with the basics and recognize that many of you have yet to build across that cloud continuum. Many of you have built on your AWS regions, but if you haven't had a chance to build with some of these other services, the fundamental question we asked was, how could we bring these cloud services you know and love closer to where that data is being produced and consumed, or in a city near you, or within the customer premise? So just to define our terms as we go from the left to the right, you take that broad and deep set of services in the region, and you can extend it to metro areas where maybe no such AWS region exists today, and that's what we'll call an AWS local zone. We can further extend those cloud services you know and love to the customer premise. 42U rack mountable compute that we bring to the customer premise. We call that an AWS outpost. And we have a number of other services here that service the customer premise, such as EKS hybrid nodes, where virtually any physical or virtual machine can connect back to a remote Kubernetes control plane managed by us, and EKS hybrid nodes. And then, of course, a number of services to support far edge devices. We're going to focus today most on local zones and outposts. We see a lot of customers. So Jesus mentioned we both supported telecommunications. It's very common for a telecommunications customer to think about using local zones and outposts to help build out their network. You might have a media and entertainment company using local zones to deliver low latency, so to service a new metro to get closer to those customers. Similarly, you might see that for gaming. But it could also be other regulated industries that are using local zones or outposts for data residency requirements. All that data must be processed in locale X. And if you bring an outpost into that premise, into your customer premise, or it happens to be within that sovereign boundary, well, now you've fulfilled that requirement. So there's a number of different use cases. It could be latency. It could be for migration. It could be for data residency. There's a number of different use cases. But let's jump ahead now that we've defined our terms.
Yeah. Also, if you're interested in more how to deploy agentic solution on the edge, after this session will be another session 302. It's going to be around deploying agentic solution on edge.
You can just come with us. We're supporting the session, so you can come right along with us. We'll run on over there. So again, we've defined our terms of the services that we're going to be working with today: regions, local zones, and outposts. and we want to talk about resilience. Of course, one of the famous quotes, everything fails all the time. How do we care for resilience? And we define resilience, as you see here, as the ability of a workload to recover from infrastructure or service disruptions. And you can think about the mental model for resilience in 3 different ways. And again, this has nothing specifically to do with hybrid and edge services. It's far broader. For any region design, you're going to think about high availability. Again, the resistance to common failures through design for a primary site. So in the case of hybrid and edge, what we're going to show you, and one of the key tenets is if you're using an AWS outpost, it's very likely that you're going to want to have multiple compute racks to have high availability. Similarly, for local zones, let's say you're deploying in the Northeast for a low latency, you're going to want to use 2 local zones, either in that same city if they're available, or nearby cities too, just like you would in the region with 2 availability zones, US East 1A and 1B, for instance. But then you can also think about disaster recovery. So how do you think about backup, managed recovery objectives? And we're going to show you how you can, because there's a lot to grasp here. And each of these concepts of high availability and disaster recovery have implications to compute in, say, Amazon EC2, or storage and RDS databases and beyond, networking. So the cognitive load to have, say, one individual be an expert in all of these design primitives for all of the services of AWS, as it applies to hybrid and edge, that's a lot. But what if we could use agentic AI and generative AI more broadly to leverage that expertise and design systems that help make prescriptive recommendations to create that resiliency? And that's exactly what we're going to do. And so if we do a good job today, in the spirit of a code talk, if the code that we purport to build delivers what we hope it covers these areas. And so we talked about the mental model of resiliency as a whole. I tried to define as I think about resilience for hybrid and edge environments, just starting from the simplest of primitives and extracting out from there. So I would say, when I think about resilience, we probably want to start with site-level resilience, that there's a physical, discrete location where that compute rack in an AWS outpost or that local zone lives, and I better hope that we have some geodiversity. I would hope that there's the networking is resilient, that there are different paths to connect point A to point B if that transfer is important to that application workflow. Compute resilience is also going to be important, that if I have, let's just say, a fundamental unit of compute, if my application requires 3 units of compute, whatever that might be, an instance type, a load balancer, well, I better have more than 3 units of compute in that discrete environment. And of course, you can extrapolate from there. So site-level resilience, compute resilience, network resilience. Data is important too, so when we start to think about high availability and disaster recovery, well, I want to have data resilience, so things like clustering, replication, and then more broadly, like operational resilience. So not any individual primitive, but how everything works together as you start to think about auto-scaling, health checking, monitoring. So if we do a good job today, these prescriptive recommendations for resiliency developed by an AI agent should be able to come up with recommendations that match those buckets. And here's how we think we're going to do it. And you could, of course, implement this differently, but here was our thought. Instead of, or to complement the experts you may already have in each of those domains, what if those experts could be represented as MCP servers? Those MCP servers were then tools provided to an agent, complemented by the logical reasoning that an LLM in Amazon Bedrock might have. It could be an Anthropic model. It could be an open weights model. Totally up to you. And there was this agentic loop. And we'll talk about more that you have a goal. And you're going to keep using those tools in your tool belt. So in this case, all the documentation for best practices that we at AWS have, plus specific knowledge of how hybrid and edge works. So what changes in the world of Outpost and local zones that we'll talk about. I gather a bunch of data. Have I achieved that goal? Yes? No? Oh, not yet. I need more information to achieve that goal. I'll continue that loop until I'm confident that I've achieved that user's result. So if we just quickly go back to that previous slide for a second, we're going to use all the resiliency primitives that we talked about before. So it's not going to just operate in isolation here. It's going to look, specifically, again, the API. So it's not just knowledge of, hey, what are general best practices? I want to know in my specific environment, what's real, what isn't, how can I make improvements? So I'm going to use an MCP server that talks to my AWS, various AWS APIs to liaise with VPC, EC2, EBS, auto-scaling, and the list goes on. Because now I can look at my entire environment, reconcile it with what those best practices exist, and suggest tailored recommendations to me. So let's jump ahead. We're going to start talking about what we are going to build here today, from static to something more advanced. Jesus, you want to talk a little bit more about what this looks like?
Sure. So basically, our idea is to start with some configuration, static file. Normally, how we would do this before, it's just gather information around our environment, see the resources that we have in terms of local zone, outposts, and then create a kind of first report. It says like kind of static report. If you think around having all the resources and say, hey, now I need to build best practice for my infrastructure. Then you are going to put some MCP servers, some tools to automatically request and fetch all these resources. And based on the knowledge of the AWS the MCP documentation part, we combine that to create a new report that is more comprehensive, right? And we will be iterating of the agent that we are going to be building. We are going to be using strands agents. For those who doesn't know strands, we will talk a little bit around it. And we will talk around how we can use multi-pattern strategy with the strands using, for example, agent as tool or swarm or workflows. So our goal today, again, this is a kind of a high-level step. We're going to be creating a static Python file for discovery. Then we're going to be creating a report based on this information. Then using Kiro CLI, we're going to be integrating some MCPs. The first one is a tool to get information around the resources automatically. Also be using MCP to get all the documentation of AWS best practice around resilience. And we will be switching this from static, from Kiro CLI, that is prompting, into a strands agent, and we'll be building a couple of strands agents.
And maybe quickly, just a show of hands, how many of you over the course of the week have had a chance either to be hands-on or attend a session covering strands or Kiro? Okay, so awesome. Good. That I was expecting. So we're maybe at 60, 70% of the room. So lucky for you today, we're going to apply all of those concepts that you started to see specifically to this hybrid and edge track of how it's not just, so there are going to be plenty of other sessions that show you, hey, on an outpost or local zone, those same telecommunications or media and entertainment or gaming companies may be running generative AI models at the edge for latency or data residency reasons. We're flipping that model on its head today and saying, okay, what you could also do is for your own edifice, use generative AI tools in the cloud to inform how you use those hybrid and edge infrastructure services in the first place.
Let's move on.
Let's do it.
So first, let's talk a little bit around our environment. Again, we are going to be using outposts. We are using a specific account. It has 5 outposts. 4 of them are active. 1 is in provisioning. We'll be running this in the Frankfurt region where we have all the resources. The first thing that we are going to be using is Kiro CLI. This Kiro CLI implements behind the scenes what we see as the agentic loop, all right? It has the capacity of reason. It has the capacity to connect to the resources. But the first thing that we're going to be using is Kiro CLI to create this kind of static files, the reports, and then move forward to create the strands agent. So for those that used to, how many of you used before Q CLI, Q developer CLI? All right, Kiro CLI is basically the evolution. It's the integration of Q developer CLI. Now it's Kiro CLI. It's part of integrating of agentic development tool. So let's move into our first step. Let me see. Let's create something here. Can you switch the?
Yep. Demo.
Yeah. So hopefully we're using internet. It doesn't fail. So let's start talking with Kiro CLI.
And can everyone see, is the screen large enough? Okay, great.
All right. For those that haven't used this before, here we are using an agent that is default. What we're seeing here is how the context is being used. So we can check more here around the context. Basically, it has 3% of some of the tools if you want to see the tools that it has already, it has, for example, one tool that is called AWS, one is the thinking, report, write, read files, and so on. So those tools already consume part of our context window because it's available directly in the Clear CLI. So I have some prompts here, so sorry, just to show you. So I'm going to be saying that I'm presenting at Rainband. I'm showing live how Clear CLI works. And for all my requests, save all the generated access and script to a specific folder. So it knows where to do the file, so we have some kind of consistency. Again, we're going to be using a specific account that has some of the outputs that we already mentioned. So this is the profile that we have. So here, now Keto CLI is validating and creating the folder. It's already there. So I'm ready to set up all the demos. What are the first thing that you want to build? So as we explained, let's move forward and create a static file. I have my prompt here. So let's see. So I'm going to be creating a Python file that is called Edge Discovery that uses HMC403, the SDK library for Python, to discover all the edge resources in this particular region. And the script must contain and discover things like availability zones, local zone, outposts. I want to see which are the instance types available on the outposts. And the script itself needs to manage all this information around error handling, throttling, and I want this on output as a JSON file.
Right.
So let's start doing this, and let's analyze what it creates so we can dive a little bit.
And key point to think about right now, this is the V1. So if we're going to think about, again, resiliency and reliability in a hybrid and edge environment, step one, even before we think about creating an agent, yes, we're using an agentic CLI tool to do so, but we're just trying to take inventory of what exists before we create prescriptive recommendations. And so that's exactly what you're going to see here.
So it already created my file. Let's check the file. First, let's try to run it. If something happened, it can automatically fix it, but let's see if it runs, and we can dive deep a little bit of the code that it generated, all right? All right, so let's see while it's running. So we set to create a file that is a static. It discovered the edge infrastructure. Basically, if we dive deep a little bit on the function it created, it goes to HMC403 using the profile that we set and the region, and it creates, and it fetch all the information around the availability zone. It have all the information around the zone ID, state, if it's local zone, whether it's where's the parent AC or the network border group that is attached. For the outpost, is doing basically the same. It's listing, it's HMC403 SDK functions to list the outposts, and basically it's getting the information around the availability zones, the instance type available, and so on. Also, we want to see from the outpost perspective, there is a content around that is called slotting. So the outpost itself is a managed service, is a hardware that a 42U hardware that you have compute nodes, and you need to specify what are the shapings or the type of EC2 instance that you want to load or have available on that configuration. So we want to see in this particular outpost that we have what are the instance types available, and also if we have some placement group, what are the placement group that we have, and let's see the results. So it ran, all right? This is the information that we got, all right? Let's dive deep a little bit on this. It's basically saying the region, the availability zones, and all the information that we just check in the Python script. Now let's move forward and say that I want to modify this script. I want to this script to be stored in a JSON file, all right? It's going to be a simple modification. Basically, we expect that it will change a little bit the last part, all right? So now we are, the output will be saved here in the edge discovery.json file. And if we run this, it will generate my file, my JSON file with the information we already saw.
While it's generating, any questions about what we're doing, why we're doing it, and sort of the sequencing here? Again, this is just we're creating a static snapshot, a point-in-time view of just, hey, what's out there? Once we have that, of course, then we'll be able to create recommendations. And one very key insight, especially for those who are seeing Outpost and local zones for the first time, these are connected edge offerings. The local zone in a given metro or an outpost sitting in your customer premise always has a parent region. It's connected to an availability zone in the region. That creates, of course, high availability, but it creates that connectedness that allows you to run API operations. And why that's important is if you see how all those outposts has an anchor availability zone, every local zone is anchored to a region, you're starting to see how that's going to create high availability best practices. You're going to want outposts anchored to different availability zones. You're going to want to have local zones with different availability zone IDs. So those same best practices continue to apply.
Let's ask even Kiro CLI to create based on the information we have, let's create a static report. Basically, we are saying like create an HTML report based on AWS best practice for the edge and considering the resources that we already discovered.
But we haven't told Kiro CLI what those best practices are, so it's got to figure it out.
Yeah, it will be using the knowledge that it was until the model that it's using, that is auto model, and we'll dive deep a little bit more on that. But it's using the knowledge base that the model itself have until the cut point time that it was trained.
Right.
All right. So if we want to use, and we will be using, if we want to use the up-to-date documentation, the latest documentation, we need to find a way to fetch that documentation, and we'll be using an MCP tool that provide access to the best practice using AWS MCP documentation. All right, for this one. Any questions so far? No, we'll be showing this.
Right now, it's just the knowledge that this large language model that's being used by default by Kiro natively knows. And the only reason it knows anything about your environment is we specifically say, hey, edge discovery.json, which we happen to know captured that point of time snapshot.
All right.
So trying to do this.
Here we go. Where we have our first, this is just generated. We're seeing
it for the first time.
For the first time as you. So we have here our information. We are 3 availability zones in the US Central 1. We have 2 local zones enabled. We have 3 wavelength zones, and we have 5 outposts. 4 of them are active. 1 is in provisioning state. And we have here all the details of the availability zones, the local zone, and the outpost. If you see the outpost itself, as Rob mentioned, is tied to a parent AC, because when we request the outpost, we do something that is called the anchor VPC, and we create a subnet in specific AC that we want to put the control plane go through that AC. So we have here 4 outposts. 2 of them in the 1A, the one that is provisioning, it doesn't have any information yet, and the other one that are spanning across the rest of the AC. If we see the best practice documentation, it shows a really comprehensive information, like your infrastructure spanning the 3 AC with outposts in each zone, providing excellent geographic distribution. There are some recommendations around there is an outpost that is in provisioning status, check what's going on, and we have multiple instance type available in terms of diversity. We have several offers around instance type in terms of the outpost rack 1. We have C5, M5, R5, and we can also have different types here. So again, this is kind of static information. We just generated the script, and now we're providing some information. Any question?
Yes.
Yeah. Yeah, you can ask Kiro, say, you can use, for example, if you're using AWS organization and you have cross-role, you can say, hey, for example, if you're using Control Tower and you have a cross-role across many, you can say, hey, use this, verify what are my accounts. It can discover your account and assume the role to perform this information across all your environment, spanning in multiple accounts.
Right.
Yeah, I have here my profile. So in the profile itself, in the AWS CLI configuration, it has the information around the account ID and the profile of the role that I'm assuming.
Right. What I mean is, I'm new to Kiro CLI, so I know exactly how that works. But every time when I use it for the first time, I don't have a profile. Give me a code and authenticate with the AWS account, etc.
Right.
If there are multiple accounts
Those are decoupled. One account is what you would have access, would give you access to Kiro, but those other accounts could simply be to pull resources. So the simplest brute force way is however you've authenticated to have access to Kiro, that remains unchanged. But you could have your AWS configuration file where you typically have your account secrets, and you could have multiple profiles, and then in that, and when you prompt Kiro CLI, you can basically say, remember we created that edge discovery.json file? We could basically say, hey, iterate through all of those AWS profiles. And then given those credentials, you're now talking to different accounts with different resources. Pull from there. And now you have a more complete set of resources reflecting that JSON. Now, how you segment by account, you would have to decide what's important to you. Yeah.
All right, so let's move forward. Again, here we are not using the tools. The tool itself is what Kiro CLI has embedded as default. It has like to-do thinking. You can enable some of these tools in the experimental part. So you see here, I have like to-do list, checkpoint, delegate, knowledge thinking. This is our part of the Kiro CLI part. But now I want to introduce a new MCP. All right, so let's create a new agent. Let's create, it's called agent 3. So here it's the configuration of the agent. Think around this. It's like you can have multiple Kiro CLI instances at the same time. Think around like profiling. So you can have one agent that has access to different tools, different MCP. In this particular case, I'm going to be adding this knowledge base MCP. So hopefully it works. So we have this is a public documentation. We will be sharing a little bit of what all the AWS MCP we have out there so you can consume. This particular MCP is an MCP that provides information around best practice, latest documentation dynamically, right? So now we have created, let's change the context and then say, I'm going to be using this agent. So if you see right now, and I go my tool, now I have new MCP here that is AWS Knowledge MCP server that have this kind of information and this kind of tools. So what if we, instead of saying create a static file, let's make something different. Let's say that I want to create a HTML report of edge resilience, best practice for my infrastructure, but I want you to find the latest documentation and using the AWS tool that it has, find the resources for me. I don't
JSON file anymore.
Yeah, you are not relying on anything, on any static file. It needs to somehow, with the agentic loop, figure out what are the resources that it needs to find based on the best practice documentation, and it create a report for me.
While the report is creating, can we take a question from the audience?
Yeah, sure.
What's the difference between the knowledge MCP server you just added and the knowledge tool that's already embedded in Cli? Do they have, are they different?
Yeah, this one?
Yeah, so I see knowledge there, and then I saw you got knowledge second. I was just curious what the difference is.
Yeah, I'm not sure. Oh, yeah, I'll take that offline. This was like Kiro was rebranded like 1 week ago. It used to be QCLI. So it introduced new features like web search and web fetch, which wasn't before on QCLI directly. So you can dive deep a little bit. I don't know if
Generally speaking, the idea would be that it's the general knowledge that the Kiro CLI must have for just coding in general and any best practices for software, whereas the more specific guidance you can give, the better. And so we've created, to keep update documentation to have a specific AWS knowledge. But it's likely, to your point, that there is some overlap.
Yeah. So if we see, go ahead.
Yeah.
Focus on this question. So the built-in knowledge, is it basically using an MCP default MCP or something like that?
Right, because those are all tools that it has, and so it need not be MCP, right? So as you'll see later, when you create a Strands agent, you can just have local tools that you'll see with like a decker. You have just some function like def, cool function, and then it just has some logic. It need not be called through MCP. That's just one way for a protocol for for an agent to talk to a tool. So in that case, it may not be called via MCP itself.
So if we see what is happening behind the scene, when I ask this kind of request, it's going to be running the tool to search the documentation, like resilient best practice for availability multi-zones, outposts and failover best practice, local zone architecture best practice, and so on. And think around is getting all this information and putting in the context, and now it needs to find all the resources that, because I want this apply for my account, it will find all the resources using the profile. It will run the CLI using this tool to get all this information and create the HTML file for us. It's going to take a while. Let's go back into the presentation to get some of the net thing that we're doing, and we can talk a little bit of the MCP servers we have there. Meanwhile, and we go back to so talking a little bit of some of the MCPs, we add this MCP, which is the knowledge MCP server, but there are other MCP servers that you can use. For example, in this particular case, we didn't add because it was built in the Kiro CLI, but you can use Cloud Control API MCP server to have access to all the resources around your AWS infrastructure. It basically have information around how to access with API and integrate with your environment. In this particular case, we didn't use it because it has already a tool that is AWS tool to get that information. Any question? All right. So we already integrate this. Let's talk a little bit around strands. Well, it generates, it hasn't finished yet, so we can talk a little bit around how now we want to move out from, we create this kind of assessment and report, but it was kind of interactive, right? Like we need to dive deep and type what we have in a prompting style. What if we want to run a kind of agent, and we want to build an agent using Python that can run, for example, in my backend system, and I can execute and can run every time I need, instead of having something that I need to prompt manually? We can create something using a Python file and an agent that can run in the backend. So that's why we're going to be using Strands Agent. Strands Agents are open source SDK for building agents. And you can use Strands with multiple LLM providers. In this case, we're going to be using Bedrock, but you can use other provider, and it has a set of tools that you can integrate, use, and make it. Want to mention something?
Sure, maybe just as we'll see in the code, maybe just a few things. When you think about an agent, it's got to have a model. It's got to have a prompt, so the brain of how it's able to logically reason, the prompt to tell it what it's doing, and then a series of tools, the actions it can take to deliver against that goal. And we believe that with Strands, it's one of the easiest ways, specifically native to AWS, to marry those three, almost like strands of DNA that are intertwined. And so the ability to just have like a really, really simple way, you can write agents in just a very few lines of code, but also native integrations. If you wanted to have a RAG workflow as part of your tools, so company-specific data, you had a specific question, and you had that RAG workflow, and you wanted to expose it as a tool, you could write a bunch of extra code to do that manually, or you could just use the native retrieve library that's already integrated with Bedrock knowledge bases. So that's an example of where the AWS integration shines with something like Strands.
So on the other hand, now we're going to be switching to use Kiro. The IDE is our agentic development platform for prototyping. In this particular case, we were using Kiro CLI. Now we are going to be using the IDE for create our first agent. And let's move on. Let's see if we should have
the report
ready. OK. It created the new report and generate this report. We can see that it have similar information, 3 availability zones, 2 local zones, 4 of 5 output, 1 of them is in provisioning state. But it has also more information around, for example, also scaling group, load balancer, placement groups. It has information also around multiple deployments of information of EC2 instance, infrastructure that spans across other load balancer, for example, that we didn't have before. So in this particular case, again, when we create this, we didn't ask any specific resources to be like static generated, or we didn't find it statically, it just find it for us. It basically discovered this placement group, local zones, and all the stuff. So it generates this for us based on the documentation that it finds, and it creates the report. So let's move into Kiro. This is the development environment. Again, we're going to be using Vibe coding. This is a code talk. let's hopefully it work. So let's start with Kiro asking something around read the documentation of strands, and based on the documentation of strands, create our first agent. So in order to read the documentation of strands, we can use an strands NCP documentation for showing that. We have this strands documentation. Let's figure out. Let's create our strands documentation agent. All right. So we can use, for example, this agent that is called a strands NCP agent. Basically, it runs OVX command. But in our particular case, you can also use, for example, you can retrieve the documentation of the software that you are building, ask the Kiro environment to read the documentation if you don't have an MCP server for that, and based on the documentation, start building on top of that.
And key point that I think you'll see here is the configuration of this agent, whether it's the Kira IDE or the Kira CLI, was almost identical. And you'll notice when you specify those MCP servers, the first time when we were looking at the AWS knowledge MCP server, it was more of a URL because it was a remote MCP server. In this case, when we're showing strands, it was a local MCP server. So it's the consistency of defining the MCP services, or rather to define these MCP servers is consistent. But it could be local, it could be remote, it could be a combination of both, it doesn't matter.
So in order to do that, again, I downloaded the documentation of strands, all right? So I'm asking to read the documentation. Also, I create a base template of a simple strands agent. So it has all the information around my profile. I could use even Kiro to say, hey, create using agent using this profile in order to avoid kind of noise, or we have a short time. I want to be focused on what we have today and focus on our configuration. So I create a kind of base agent that it says, I'm going to be using this profile. I'm going to be using a structured response in strands. That means, for example, if you want the output of your agent to be a structure, let's suppose that you are returning a person object. You want to have a name, you want to have the age. So you can create a kind of, when you create the agent, you say, hey, use a static output. In this particular, I'm going to be asking for a markdown report. So, and these are just placeholder, right? This is our main loop, and we are going to be creating using our profile. I'm going to be creating a runtime client for Bedrock with 300 seconds to create the client. Then I'm going to be creating the agent itself and asking the agent for something. This is a place.
That's the most important part, quickly, folks. If this is your first time dealing with strands, four lines of code, really 3 if you exclude the closing parentheses. When we say you can define an agent in 3 lines of code, that's what we mean. You see the system prompt, you see the model, you see the agent instantiation, and that's it.
That's it. So I'm going to be asking to, using the strands documentation from this folder, create an agent with a strands name of B1 using this base, and basically the script should be running using this model. The 300 seconds is there for read timeout. And also, we are going to be using some tools similar to the static file that we created to create some information around get outposts, get local zone, availability zones, and so on. So behind the scenes is going to be creating several functions to get information similar to the Python file that we created at the beginning. So let's go and ask Kira to do that for us. Meanwhile, this create the file, all right, is reading the documentation. I have a backup here. We can show how it's going to be the code that it's going to be generating. I'm going to be leaving this generating the code, but we can start reading how the code will look like. Shall we do that? Let's go. So now it's doing, all right, but let's see, in order to get some of the time.
And let's go back to I think let's start with the agent instantiation. Show what's the same, and then let's show what's different, what the agent did. So we should still see somewhere in the middle of the file, it instantiated the agent just like it did before.
Yeah.
But
let's go to the agent part, where we define the agent. So we have our main part, where we have our config, our Bedrock client, the model itself, and now we are creating an agent. And we are saying that you have some tools. Which tools are these? Basically, we asked to create some kind of functions where it can fetch information around outposts, local zones, availability zones, EC2, RDS, you mentioned. So in this particular case, we are creating this agent, and the system prompt for the agent, it's basically this. You are an AWS Edge Infrastructure Resilient Expert, and your role is to analyze the AWS infrastructure deployment and provide comprehensive resilience assessment. And your analysis should cover, and there's a lot of points that it needs to cover. This is being generated right now, right away, but I have a backup here just to show this. So as when we create this, we asked to create a kind of tools, all right, like EC2 instance, which are, now it's running. Meanwhile it's running, I'll be showing this. So if you want to see the tools that we created, we asked to create like get outpost. So it's using both of three, the client, to list the outposts and list all the resources, pretty similar to the Python file that we created at the beginning. So after it run, it's running right now. So it just created the new one. Let's see, not the backup. Let's see the one that it actually created. Should be pretty similar, which is running right now. So it's conducting a comprehensive AWS structure resilience analysis on the US Central 1 region, and it's calling the tools. It's calling get output, get local zone, get availability zones, instance, all the stuff. And now it's basically outputting. It's creating my output. This is the report that is going to be saved in 1 second after it finished with my MD, with all the information that I have. Any questions so far?
And I think just a key learning objective is no surprise that the individual tools that are being instantiated, like get outpost, is going to be using almost identical code to that first program we created that describes the EC2 instances that are available, or describes the availability zones, the local zones, and the outposts that are available anchored to that region. So it's just we're taking these little primitives, these functions, and showing it can be standalone Python file, it can be part of a tool that talks to an agent. It can be embedded into some remote MCP server that our CLI or agent talks to. It's just different ways of using the generative AI toolkit in AWS to get the results you need, and often much faster than doing so manually.
So now it's basically the output of all the information that it's providing. Once it finishes, it should generate a file with an MD that, as we ask, like the big one. And I think it should be finishing in a couple of seconds. Hopefully it works. After this, we are going to be doing something similar to what we did with Curiosity Line. What if we say, hey, just remove all these tools, and let's use a tool that can provide access to my environment. I don't want to define any kind of tool and simplify my agent saying, now you are an expert, you have access to my AWS infrastructure, you have access to the AWS documentation, do it what I need. It's going to be simplifying our code of a Strands agent in less than 100 lines. So, all right. Any questions so far?
I have a question. But in terms of cost, how many credits cost this exercise?
Yeah, so when you're running Strands, you can use the metrics tool. So it generates how many input token and output tokens it's consuming.
For example, your particular exercise, this one, how much it costs?
Yeah, it should be printing the metrics here. I think I have right now. In the
We
base.
haven't benchmarked this exercise in the specific number of credits that it would consume in Kiro yet. Yeah.
Yeah, so I don't have right away the point, but we can do the exercise and provide print the metrics for you. Yeah. So. Yeah. All right. So going back to the report, if you want to see the report, is the MD. It has pretty extensive documentation. It should have also some recommendation around buckets, information that we didn't have before, and also some links around documentation and even some code of how to modify, for example, the load balancer that we identified that is running spanning on a multiple AC and so on. Again, if we want to simplify this a little bit of the code, because now our V1 version is more than 500 lines of code that we may not need all of them. So what if we say that I want to create a new version, all right, it's going to be V2. Let me show you the prompt here. So I'm going to be creating a new version of this resilience agent, but based on the first one, but with an additional tool. I want to configure the MCP, the knowledge MCP server, and also remove all the tools to get resources from AWS, instead use the predefined use AWS tool that comes from Strands. So the idea here is just to simplify the code, and similar to what we did in the first Kiro CLI, it's going to be creating a Python file with a Strands agent that is simple to read, and basically it's prompting. So again, let's see how it should look like while it generates the code for us. So can you read there? Okay. So it's pretty similar. We have the response in a structured format, output response. But now we have a system prompt saying that similar. You are an AWS Edge resilient expert. You have access to real-time AWS documentation, and your role is to analyze the infrastructure deployment and provide a comprehensive resilient report. Pretty similar. We have our model. Now we have this MCP client that is a streamable HTTP client that it has access to the endpoint of the MCP. And we are creating an agent that with a model and saying, like, now you are going to be using this tool. Use AWS. This is a tool that is embedded in Strands. We will see it here in the Strands tool. You can find more tools available on the documentation on GitHub, on the Strands tools repo. And also now we're going to be using the AWS Knowledge MCP, that it's basically what we defined before.
And instead of having all those tools, get Outpost, get availability zones, get AC2 instances, you could define all those tools manually, or you could have your Strands agent in turn be an MCP client that connects to these remote MCP servers, saving you a bunch of time.
Now, if you see, it's running, the V2 version. It's using the tools to get all the resources documentation, and also it's using the AWS search documentation itself. Now it's pretty similar to the second version that we did with Kiro CLI, saying like, hey, now you have access to the tool, now you have access to the AWS environment, and just figure out and do all the things that you need in order to get that information for me. So once we run that, we should get a report pretty similar to the first one, maybe with more details, because now it's conducting, okay, it's printing here. It has access to more resources because it can think. Instead of saying static, oh, you have access to the ALB, you have access to the EC2, it can figure out, oh, I need access to the placement group. I need access to understand what are the S3, how is the NLBs or whatever resources are spanning across our infrastructure. It's generating that. I'm going to be showing a one that is similar. We just created this. But basically, the output should be something similar of what we are running, right? So any question here? No? Yeah.
So I see instantiating agent. I'm just curious about the code itself. What's
Yeah.
the event loop for the agent loop? Are we just like calling agent.run and it's just
Yeah, so let's say the code of the agent loop part here. So the agent itself, it's basically you have to select which is the model, all right? And you can have different model provider here. You can use OpenAI, you can use Bedrock. In this particular case, we're using Bedrock, but you can implement even your own provider, all right? And then you have a set of tools that it's available, the system prompt, and then when you want to call it, it's basically agent, it's like, do this, run this execution for me. And this is the prompt that we're asking the agent. The agent, what we're asking is, please conduct a comprehensive AWS infrastructure resilience analysis for this region. It's a variable that is passing, and the report must be generated on the current date, all right, today, and include the following things. Edge infrastructure report, it generates that for you. So it's kind of, you define what is the system from the agent, the tools available, and then you ask the things. So in order to have a response that is a structure, you need to pass this argument that is a structure output model, and it's basically a class that says in description mode what is the model the agent needs to fulfill as a response, all right? Suppose that you have an agent that validates information for a person. You may need to have age, name, address, whatever. You may ask something, and then you can ask directly information response, a structure response, that age, and you have the information there. Clear? We have 8 more minutes. Awesome. So it's going to be generating this. Let's dive deep a little bit on what we have. While this is generated, let's talk a little bit of how we can create multi-agent patterns on strands. So now we saw information around, okay, now we have the code, we have access to some tools, and we can create a new version that has multiple agents. Instead of having isolated tools, what if we can create an agent that is an expert of a sysadmin, for example, AWS sysadmin. It has access to your AWS environment, and it can do read operation, write operation, whatever is the scope of the agent. So it has access to a specific tool. Then you can do an AWS documentation expert, where it has access to the MCP of the AWS knowledge. And then you can figure out and say, hey, I want a coordinator that I want you to, I will be sending a request, and using those agents, it will figure out, it will have as a tool, it will figure out and perform the action for me. So this one is going to be the third agent that we are going to be implementing. I think we have time. But then we have other kind of pattern. We can do something like, instead of having agents and pack that and provide that agent as a tool for other agents, we can do a kind of graph where this agent can talk with other in a kind of DAG, direct graph. So we can say which is the flow, like I'm the researcher, I'm going to be passing the information to the writer, and the writer pass the information to the reviewer, and the reviewer print the output, for example. And it's just a kind of graph information. And then we can create a kind of workflow that in the graph we can go back and we can define the transitions going back and forth, but it's established transition, all right, stable transitions. And in the kind of workflow, it's basically a structured coordinator of tasks that we can define. First step, do this. Second step, do whatever, like researching, like coding, all right? If we want to code an application, maybe we need to figure out first is the architecture itself, the coder, the tester, and the reviewer, and so on. So we can create a kind of flow. Third, we have the swarm pattern. In the swarm pattern, it's a kind of multi-agent that there is no a single coordinator. It's basically between them, they figure out the task, and you can specify the swarm agent in 2 different ways. You can define a swarm agent saying like, hey, you have this complex task, create the agents that are expert in each particular area, and each particular area, they start talking each other as they believe they need to do, or you can specify specific agents. You can create agents like AWS documentation expert, the sysadmin expert, the report expert, and then as a whole say like, hey, I have this problem, figure out how to solve it. And they will be passing information like, hey, I need to talk with the expert saying like, hey, I need to talk with a system admin to get this information. Go back to the other documentation expert, and they can retrieve the information and work as a whole, sharing information across the agent dynamically. You want to see the code of Swarm, how it looks like. I have a couple of examples here. So still generating the file. Let me close this a second. So in the Swarm part, we are saying here that, again, we have our response, but then we are creating agent 1. You are the infrastructure expert. Your name is infrastructure discovery, and you are an agent that is specialized in discovering and cataloging AWS resources. So it have access to the tool use AWS. Second, we have an agent that is the best practice. It has access to the AWS Knowledge MCP. Third, we have an agent that it says that what is the gap analysis. It doesn't have any kind of tool, but it says based on the specialized agent, all right, comparing our infrastructure versus the best practice, which are the gaps, all right? And it figures out what are the gaps and what we need to do in order to make our infrastructure pretty similar or compare against the AWS best practice. And then we have the recommendation. Again, you are a recommendation agent based on the previous information, just gather and create an actionable remediation plan for that. And based on that, we create a swarm. And it says like, okay, let's create a swarm where we have all these agents. The first that will receive this is the infrastructure agent. You can put the best practice, whatever you want, and you have some transition and match iteration that you can take. As we don't define how the transition will look like, is start talking each other like, hey, I'm the expert of this information. So it passes information to the other one, and it just create a kind of mesh loop, and instead having interaction between all the agents. And the agent as tool, all right, which is, let me see if this finish, we can ask our third version to create a agent as tool. I'll be sharing here. But the agent as tool, now what we are saying is, all right, now I just want to have an expert that it's AWS sysadmin expert, and we define this as a tool. But if you see the implementation code of this tool, is again, it's an agent. So we have the same pattern. We have an agent with a model, we have a tool, but we are exposing this function, which is an agent itself, as a tool that can be consumed by another agent as a coordinator agent. All right, so we can create a kind of tree where we have a coordinator talking with other agents that are being exposed as a tool. In this case, we have a sysadmin expert that have access to the use AWS tool. We have a documentation expert that have access to the MCP. And all right, and we have finally the coordinator that provide information to both tools, and it provides information for you.
So that's about all the time we have left here, but just to give you, I guess, a little bit of parting wisdom, we recognize that we had to make trade-offs in this session of going all in on what those best practices are for resiliency while trying to introduce all these primitives for generative AI and agentic AI specifically. And we thought that to strike a healthy balance, we would show you how to go from a static resiliency report with a simple Python file to starting to integrate MCP servers, Strands agents, Kiro CLI and Kiro's IDE. And to take that one step further, if you've had sessions that you've seen around Agent Core, you could run that Strands agent that we created in Agent Core. So you don't have to run it remotely on your laptop. You could have it running in that secure, isolated environment. So we hope that this painted a picture of what the future of, let's say, your well-architected framework review could look like for your applications using AWS hybrid and edge services or otherwise. If you're interested in getting a little bit more hands-on with hybrid and edge services, come with us just across the hall here for this next workshop. We hope you had fun here over the past hour. Thanks for hanging out with us, and we'll stick around to answer any questions and look into that credits question you asked. So thanks so much, folks. We appreciate it.